Okay, chapter 15 is the 6th chapter of organic chemistry. 10, 11, 12, 13, 14, 15. So when we're done today, and we'll try to cover all of chapter 15 today, we will have completed the first portion of this course, which is organic chemistry. And then tomorrow we'll start biochemistry. All right, so chapters 10, 11, carbon and hydrogen only. 12, 13, and 14, carbon, hydrogen, and oxygen. 3 elements. Carbon, hydrogen, and oxygen. And we tossed in a little bit of halogens sometimes. Chapter 15, we're adding our next element, nitrogen. And we're going to be studying, I need a really bright one. Really good one here. We're going to be studying amines. Amines, NH2 groups. Put it up there. That's a C, by the way. They got an NH2 group on them. These are amides, or amines. All right? Both have nitrogen. Big difference. This nitrogen is next to a carbonyl. Carbon-oxygen double bond. Carbon-oxygen double bond and an amine is an amide. And just the amine group, this is actually an amino. This is what we'll refer to it as. When you see this group, it's an amino group. An amino. So this is what chapter 15 is about. There's not going to be a lot of reactions. There'll be a few reactions that we'll talk about in chapter 15. The challenge in chapter 15 is that amines end up with several different ways of naming them. 2 of them are IUPAC. So IUPAC has 2 approaches to naming amines. They're both accepted by IUPAC. And then there's a common or simple, a simpler naming simple amines. So because of the variety of ways that you can name amines, it gets a little bit challenging to figure out what's the name of this amine. Okay, so that's what we'll do. I got 6 of them here. We've got 6 of them here that we'll name, and then I've got a bunch, 2, 4, 6, 8, 10, 12 that we'll draw. All right, so naming and drawing will be first hour and a half here. If we could get that far, that'd be good. Then we can talk a little bit about reactions and go from there. Okay? Mackenzie, do you have your chapter 13 home? 14? Okay. I wanted to get that from you before I hand it back. All right, chapter 15. This is what I just told you. Okay, here's an amine group, and you got N with 2 hydrogens. Right away here I'm showing you one. It's got 1 hydrogen. It's got 2 methyl groups on it. That's an amine. There's going to be a bunch of different amines. So we can take a hydrogen off here, put another carbon on there. That's still an amine. We could actually take that hydrogen off of there, put another carbon on there, and it's still an amine. It doesn't become an amide until you see right here, you got a carbon-oxygen double bond with a nitrogen next to it on the same carbon. So the carbonyl has a nitrogen on it. Then you've got an amide. We'll concentrate on amines, and we'll give amides a little bit of attention. What are amines? Amines are organic derivatives of ammonia. All right, so we're going to have to go back in our 1305 filing cabinet, go back in there and look at ammonia for a second and get familiar with ammonia, because then we're going to be substituting organic substituents onto that ammonia and converting them into amines. All right, so here I'll draw a little, we'll work with this a little bit. Here's ammonia. All right, before we get into the amine, let's look at ammonia. Let's look at nitrogen first. Nitrogen, atomic number 7. It's in the 5A group, which means it has how many valence electrons? 5. Good. Boy, you got back into that 1305 filing cabinet. 5 valence electrons. All right? So it has a non-bonded pair of electrons right there. It doesn't need to bond with anything to satisfy that. It needs to bond with something there, and something there. So it ends up sharing electrons with 3 hydrogens, and you get to this molecule, which is ammonia. And we write it NH3. I just want you to, where carbon forms 4 bonds, oxygen forms only 2 bonds because it has 2 lone pairs of electrons there. They're all wanting 8 electrons around them, right? And they all get 8 electrons around them. Carbon needs to bond with 4 other things to get those 8 electrons. Oxygen, 2 other things. Nitrogen, 3. Okay, now let's just remind ourselves of one other thing. Is ammonia an acid or a base? Base. Acid. Base. Acid. Base. You see the hydrogen, might be an acid. Blessing's right, it's a base. Because when you put this in water, remember, when you put this in water, it forms the ammonium ion. How does it do that? It takes a hydrogen off of the water, forms this ion. And what's it do? It renders the solution basic, because the other half of the water molecule is floating around as a hydroxyl, which is a base. It's a weak base. Anybody know what ammonia is in? Around the house? I can't hear you.
The cleaning supplies?
Well, it could be in there, but most typically it's in Windex, because you can spray it on glass and you can wipe it off, and if there's any ammonia left, it evaporates, leaves no residue. Okay, I don't know why they put that blue color in there. That's all it is, blue color. Ammonia isn't blue, it's colorless. I guess they put the blue color in there so the Windex will leave streaks. I don't know why they do that. I guess if they sold you a clear bottle with no color, you'd think, I wonder what's in there. So they put blue food coloring in there or something. But ammonia is not blue. Okay, but it's a weak base. Most soaps are basic, and that does help them be work as soaps, but most of your other soaps have sodium hydroxide, or they might have some ammonia in them. Okay, so keep this in mind, because even when we go over to the amines, we're gonna be revisiting this kind of behavior, even with an amine, when we start putting carbons on here. Okay, so amines are Organic derivatives of ammonia. So we're gonna, what that means is we're gonna start pulling off a hydrogen and replacing it with a carbon. And you can see you could do that 3 times. You could have R1 could be a methyl group, R2 and 3 could be hydrogens, R1 and 2 could be methyl groups, and R3 is a hydrogen, whatever. Okay, classification of amines. There are primary, secondary, and tertiary amines. Ammonia is ammonia. But if we come over here to methylamine, we've got an NH2, like I'm pointing right here, an NH2, and we've got a methyl group on it. So we have 1 carbon and 2 hydrogens. That's a primary amine. So we're basically asking how many carbons are attached to the nitrogen. 1 is primary. 2, secondary. 3, see there's no hydrogen? No hydrogen now. We got 3 methyl groups here. No hydrogen. That's a tertiary amine. This is, these names are the best names to be applying to these because they are simple amines. It's methylamine, dimethylamine, trimethylamine. When you can name an amine simply, then that's the thing to do. One of the things, I said naming is a little bit more challenging here, but one of the things that I will do, I need to go into the exam and make sure it works this way. On the last exam, for example, I might have said, you might have had a question that said, give the common name of this alcohol. And it might have had this alcohol. And then you might have gone on, let's say that was question 1, you get down, there's another question, it says give the IUPAC name of this alcohol. And it had this alcohol, same alcohol. So what's the answer to this question? Isopropyl alcohol. And what's the answer to this question? 2-propanol. All right, so, and I know that the exam, the question bank I'm pulling these questions from, even on amines, it's going to have these kinds of questions. This kind of questions you have at the end of chapter 15. It'll say, give the common name of this amine, give the IUPAC name of this amine. What I will try to do is, what I'm going to try to do is go in and change all those questions that are like that, and just says, give and name this amine. And you can name it using IUPAC or common, but it has to be an accurate name of it. I don't care whether you give it a simple name, an IUPAC name, or use either one of the IUPAC systems. What's the bottom line criteria? An organic chemist needs to know what amine you're talking about when you use that name. It can't be ambiguous and lead them to, I don't know what amine they're talking about here. It's not an appropriate name for that molecule, okay? So in chapter 15, so you can even decide, for example, this is methylamine. That's a simple name. You can see the methyl group, methylamine. The IUPAC name is methanamine. You take methane and drop the E and add amine to it, and you get methanamine. And there's another name for it. We won't go into all of them right away here. Okay? So, do know how to classify an amine by seeing how many carbons are attached to it. And let me just, let's take methylamine for an example here. Let's say you're given, it says draw methylamine. Okay, it says draw methylamine. So you come down here and you say, okay, I know amines are going to have 3 bonds on them. It says this has a methyl group. Okay, I'll put a methyl group on there. The name says there's only 1 methyl. If there was more than 1 methyl, it would say it. Okay? It would say dimethyl or trimethyl. It says methyl. So what are the other 2 bonds have to be satisfied with? Hydrogens. Okay?
So it's just assumed, right?
Pardon me?
It's assumed that you know that?
Yeah, it's assumed you know that. It's assumed that you know that an amine has 3 bonds. And if I'm giving you the name of an organic amine and I'm only naming 1 substituent on it, the other 2 have to be hydrogens. So if we come over here and the question was draw dimethylamine, all right, you're going to say, okay, my amine has 3 bonds on it. I'm going to put 2 methyls on there. That's going to only have 1 hydrogen. All right? So don't, I said these are amines, but don't just assume in every case there's going to be 2 hydrogens on that nitrogen. Depends on how many carbons are on there. There's only room for 3 things for an amine. Okay? Well, while we're at it, go ahead and draw ethyl methyl amine. Draw ethyl methyl amine. Okay, so here's where you start. It's where you start. It says it's an amine, so you'll put an ethyl group. Doesn't matter where you put the ethyl group. And then you put a hydrogen. So it doesn't, you could have the methyl group over here, you could have the ethyl group over here, and the hydrogen. It doesn't matter what positions they're in. There's just going to be a methyl, an ethyl, and a hydrogen. Let's see, did I miss anything? Okay. So important thing on this slide is classifying them, primary, secondary, tertiary. Okay, let's classify these. Classify. We won't worry, we're going to come back and name these in a minute, but let's just classify them. The top one is what kind of an amine? Tertiary. The next one? Primary amine. The next one? Secondary amine. The next one. That next one. Tertiary amine. And the last one. Secondary. Okay? Pretty straightforward. All right, so nomenclature. We're getting into nomenclature. Common names. And how do I work with amines? When I can use a common name, I use it because it's the simplest name for an amine. When can I use it? Well, if all you're talking about are methyls, ethyls, propyls, isopropyl groups, maybe even phenols, or a butyl, just a straight normal butyl, you could just use this simple naming. So here's methylamine. We looked at methylamine, dimethylamine, trimethylamine. I had to draw ethylmethylamine, ethylamine. So when they're just these very short little alkyl substituents, this is the best way to name them. Simple. You just have to, you got 3 methyls, you got to make sure you put the prefix in front of it. Just say there are 3 methyls. All right, IUPAC. In the IUPAC nomenclature, the one system, and the one that I prefer using, again, the book seems to prefer the other one. I can see in some of the questions and stuff, but is to think of this as an amino group, just like you would think of an OH as a hydroxy. So where this is a hydroxy substituent, and you've already seen names of molecules where at times you need to use this in the name, hydroxy. The best way to think about this is an amino substituent. So yeah, here's 1, 2, 3, 4, 5, and if I were to just call that pentylamine, if you say pentylamine, I go, I wonder where on the pentyl the nitrogen is attached. It could be attached right at the end. It could be attached right here. It could be attached right there. So it could be attached at the first, second, or third carbon. So this ends up being, when you start getting longer carbons and a lot more options for where the nitrogen can be attached to that chain, it's better to go over to here. 1, 2, 3, 4, 5. We're going to call this pentane with an amino substituent on the second carbon, just as if it was a chloro or a hydroxy or anything, or a methyl group. If there was a methyl there, it'd be 2-methylpentane. This is 2-aminopentane. Okay, this is good. Okay, here we got an amine and an alcohol on the same molecule. So what we're doing here is treating this as an alcohol, and it's not 2-propanol, it's 1-propanol. So if that's 1, 2, 3, it's 3-amino 1-propanol.
Well, what was in the alcohol first? Is there a rule?
If you treated it as an amine first and named the alcohol as a hydroxy, that would be acceptable too. In that case, it would be 3-hydroxy 1-aminopropane. Okay? That would, if you told me that name, I'd be able to draw that. I'd know exactly what molecule you're talking about. So, but I think the book is going to be treating alcohols as they're going to give precedence to the alcohol. I talked with Dr. Nair. He and I talked this morning about it, and he said you'll see them both ways. So yeah.
So, clarify, the OH is always going to take priority in the numbering of the carbons.
Okay, here's a good default. Whenever you invoke this functionality into the parent name, then start numbering the carbons based on it. Okay? So if we're going to call this propanol, and that OH is on that carbon, that's going to be the number 1 carbon, because this is the parent name, okay? So that's driving the numbering of the carbons. And so then that means that's 3. So if we called this 1-amino 3-propanol, that would be a little froggy, because now we're saying this is going to be carbon number 3, and yet there's the parent name. That's not right. This is going to be carbon number 1, because we have this OH specified in the parent name. And I just say that in general, whether it be a whatever else it is, an aldehyde, a ketone, whatever. If you're pulling that into the parent name, then you're going to number your carbons based off of that functional group. What gets you to that functional group first? Quickest. There's a diamine right there. 1,3-diaminopropane. So there's propane, and we got an amino group on carbons 1 and 3. Okay, so let's look at this one. So we'll look at all 3 of the ways of naming this. Like I said, the simple name here is methylamine. That's the simple name. The name from the previous thing would be called 1-amino. 1-amino what? Methane. So this is a common name. This is an IUPAC name. And this is an IUPAC name. Methanamine. So,
question for the names, because I know the answer in the test. I got it wrong because I think it was 3-hydroxane. The H was capital letter and it was wrong. So you have it as a capital there.
yeah, that's a question I will. The name was hexine.
Mm-hmm.
It had 2-hexine and 2-hexine. I will go in and correct that. The capital is no big deal. Okay?
Question.
Doesn't matter whether it's capital or lowercase.
Okay, that one might.
Doesn't matter. And I don't think I corrected that yet for everybody, but if somebody had the right name and it just was capital versus not capital, that's a bogus. It shouldn't have had those 2 different answers in there. Should have just had one answer, and it didn't matter whether it was capital or lowercase.
What about the question that had to do with toluene, the common name and the IUPAC name? One was capital, one was small.
Same way with toluene. Yeah, I've been making so many worksheets I haven't been able to go in there and clean up the exam. But there's only a couple little corrections, so your grade won't change dramatically. But if that was the difference, it'll be corrected. Should be corrected. All right, so I kind of lean on this. For a simple one, yeah, a simple name or common name. And then you can see the 2 different ways that IUPAC works with this.
Professor, I have another question too. You wrote it with a space between the 2 words, and over here it doesn't have a space. So which way should we write it down? Or it doesn't matter?
Again, I don't think it matters. I think in papers you'd probably see it both ways. I like to put a space between there. It kind of, sometimes these names get really, really long, and it's kind of nice to see a propyl something or other. Oh, let's see, we didn't. Okay, so there's methylamine. This is So here's one propanamine. We didn't need a number here. There's only one carbon. But here is one propanamine, or it would be one amino propane. So these are the two different IUPAC names. One propanamine, here's 2-pentanamine, or 2-amino pentane. Okay, let's I hand this out. I think to save my feet, I'm going to hand these out to the front of the column. 5, 4, 5. 1, 2, 3, 4, 5. Pass those back, please. 2, 4, 6. 1, 2, 3, 4, 6. Should have kept myself one. Here's what we'll do. Okay, don't do all of those, but let's name 4 of those here. Let's go over here. All right. Let me try to find this. Okay, for right now, this is how far we've gotten. So name this one, and you can name this one, and this one, and this one. Those 4. Don't worry about the other 2 yet. Those are amines. One of these is an amide, and one of them is a little bit more complicated amine. So go ahead and try to name those 4 amines. And attendance-wise, you're all here, so that's easy. I like that. And again, give you opportunities to come up. And you know what? Everybody came to the board yesterday. So I don't know if we have to. I didn't expect that. I was thinking, oh, we'll try to get half the class to the board yesterday and maybe the other half today. You all got to the board yesterday. So do that again, as many of you as you want to. Just jump up there. Feel free to erase this stuff. And see these people that jumped up? They've learned something. They get harder. They get harder with time. So they said, okay, if we're going to do this, now's the time to do it. I like eagerness. Today's the 23rd. And I'll give, I give credit for participation. You don't have them? Okay. Couldn't put them on. Back in my office.
Okay.
I'll try to get you.
I'll just ask you after.
Yeah. Okay. Who just said? Okay, Brianna.
Is the same one?
Caitlin. Alejandra. Okay, and coming up to the board, it doesn't matter whether you get it correct or not. This is just participation. We will correct it if need be. And the criteria here is that you give an accurate name. We may go ahead and give all the names we can. But is the name accurate? Yeah, because see, if you had a propyl, you would have to have 3 carbons in a row. Okay, don't say 1, 2, 3. That's not in a row. Okay, that's a methyl, that's a methyl, and that's an ethyl. Ethyl dimethylamine. Yeah, good. Yeah. Okay, let's take a look at which one is this one. This one's right here. This one's right there. These are kind of tiny. Now, I am not even going to get into what the IUPAC names are here. And we don't need these dashes either. Just ethyl dimethylamine. There's 1 ethyl, there's 2 dimethyls, or there's 2 methyls, so dimethylamine.
Excuse me. What if I have gone with dimethyl first? Would it have been dimethyl or ethyl?
Yeah, dimethylethylamine is fine too. All right, on amines, I'm not going to get bothered about what order you put them in. If you had chloro, yeah, we'll see here in a minute. All right, this really wouldn't even be worth saying, okay, what's the IUPAC name for that? We could get an IUPAC name for that, but it would get ugly. And this is simple, so go with the common name. Okay, we need to take a look here. This looks like a methyl group, doesn't it? Yeah, but it's not, because let's put it down here. We got a CH3, a CH2, we've got a CH, and we've got a CH3. All right, who named this? Okay, let's name it again, Caitlin. Now what would you name it? See, all I did was just straighten that out. And it's not 3 carbons long, it's 4. So it's not propane, it's butane. Okay? It looks like that. Okay, this is sometimes the way they're written kind of lead you down a path, and it led down a path here that makes a lot of sense. But that's 4 carbons in a row. And the amino group is on what carbon? 2. All right? So we'll take that one out of there and change it to that name. Okay, now let me just say this. Sometimes, if let's take this as an example. this is a mistake that I have seen students make. They look at that and they go, oh, we got 3 carbons in a row. You don't. You got a nitrogen in the middle, all right? So this isn't a propane. Don't look at those 3 carbons and say, oh, this is propane. No, the longest carbon chain, so when you're looking for the longest chain with amines, you're looking at the longest chain of carbons. And then you're looking for where the nitrogen is attached to that chain. So this is going to be a simple name again. It's going to be what? Ethyl methyl amine. All right. So we got this one. Oh, this is that. No?
No.
Is that another one? Oh, okay. Okay, so really this one and this one are the same, aren't they? This one is just written right along, and it goes to 2-aminobutane. It looks like 2-aminobutane. If we made a model of this, we could twist this around and get it into that shape. So they're both 2-aminobutane. All right. Okay, this is a little tiny over here. Oh, there's 2-aminobutane. All right, but here, like, what do we need to change here? We got 2-butamine, butanamine. Remember, you take the butane and you drop the E, butanamine. So don't drop the N and the E and the A, just drop the E. So butane becomes butanamine. And was this one of them? Okay, 1, 2, 3, 4, 5, 6. And this is on 1, 2, 3. 3-aminohexane. Need an E on the end there. 3-aminohexane. Good. Okay. Now let's go on. Go back to our slides, wherever they are. Where'd they go? Right there. All right. Okay, now we'll learn how to use N, and I think the best way to look at this is to first introduce our aromatic amine. This should be a 3x5 card. Got a benzene ring, and we have an amine on it, and it is called aniline. Aniline. So now you got benzene, toluene, phenol, benzaldehyde, benzoic acid, and aniline. This is a whole series of aromatic molecules with a new functionality on it. Aniline. Now, for you to understand, you're going to see the letter N show up in the names of molecules, and I want you to see why. So I'm going to draw a molecule here. And I'm going to draw another molecule right next to it. These are all aniline of one form or another. They're all aniline. Got a benzene ring with an amine on the benzene ring, so aniline. The only thing I did on these two molecules is I added a methyl group. Here I added the methyl group to the nitrogen. And here I added the methyl group to the benzene ring. All right, so they're both going to be methyl aniline. But how do we distinguish them from one another? Methyl aniline. Methyl aniline. Okay, a minute ago I said whenever the parent name includes a certain functionality, that's where you're going to start numbering the carbons, okay? So that's carbon number 1 up there. This is carbon number 1. 1. 1. So what do I need to put in here to specify this? 3. 3 methyl aniline. What do I put for that one? No, 1 is the carbon. If I put 1, it would suggest that the methyl group is attached to the first carbon. It isn't. No, we're going to use the letter N. It's going to be N-methyl aniline. So N is going to become a designator of a position for a substituent when you have a substituent on the nitrogen. So that's N-methyl aniline, 3-methyl aniline, and here's aniline. All right?
You put like that little dot inside the ring, is that?
That's a number 1.
Oh, that's.
I'm just numbering 1, 2, 3. That's a little 1. It's just designating what carbon number it was on. So that you can see then that you're... Remember this was ortho, meta, para, so this could also be metamethyl aniline. We won't worry too much about that. Just... All right. So I hope that helps you see that there are times when we're going to have to use the capital letter N for nitrogen to indicate that this methyl group is on that's the position it's at. Just the same way we would use a number to number the carbons in a chain. It's a location. Yes?
Does the number 1 always start on the top, or will it always start on the one that has the
Yeah, it doesn't have to be at the top. I mean, I could draw this molecule like this.
And
1 starts right there.
So if there's other substituents on it, then you would go start at 1 and go.
Right, we would count from there. And we would count to them in the shortest distance. You know, so if there was another one right here, that would be, that would be position number 2. I wouldn't count around number 5. Yeah, the carbon number 1 is the one that carries the nitrogen. Because we're going to name this aniline. And what is aniline? Aniline is a benzene ring with a nitrogen on it, and wherever that is attached will be carbon 1. Good questions. Okay, now, Now let's go back and name these amines. We classified these a minute ago. Let's name them. Yeah, go ahead and name all of those. You don't necessarily have them on the worksheet, but why don't you write out some of these names? And if taller people want to come here and write the name on the top, and or pick one. Pick one that you're comfortable writing the name on. If you get down naming amines, then you're over the biggest hurdle in chapter 15. So work at this and you'll have the lion's share of the work for chapter 15. If you want to, Samantha, just name one right next to it.
She's doing one. That's fine.
Can you put it right on there? Just write it right next to the molecule. You don't even have to draw the molecule. Just write the name next to it. Dimeth. Only got one carbon in it, so that wouldn't be the main chain. Yeah. That's all right. That's good.
Nope. Got it.
Crystal. Yeah. Yeah.
I totally messed that up.
What? No. Oh, methyl. That's pretty good. That's good. Yeah, methyl propylamine. Yeah, methyl propylamine. I like that. I was going to methanamine. Yeah, okay. Who else just went up there? Gail, Crystal. Oh, Blessing. All right. What do we do? Do we have this one over here? Do we have this one? Yeah. So we have.
Name them like that, right?
Butanamine. So we don't need the E. You drop that E. Butanamine. So you drop the E and add amine. Now, the simple, and I would probably accept that, would be something like ethyl, butyl, ethyl, methylamine. That'd be one way. This is starting to get kind of long, and we know that butyls can have 4 different ways it's arranged, but I think I would accept that. If I saw butyl, I would think it's arranged like that. If we come into a name like this, keep in mind, we could have a methyl here. We don't. The methyl's on the nitrogen. So we have to say that. This is N-ethyl, N-methyl, 1-butanamine. All right, where is this methyl? Where is this ethyl? It's on the nitrogen.
Professor, and that would be the IUPAC name?
Yeah, this would be an IUPAC name. This is a common name. Yeah. Let me just put I'll put another one up here after we get all these. So here's methylpropylamine. I was going to go into an IUPAC name here, but I like this better. It's simple. This is a common name. All we got on there is a methyl and a propyl. Just know that distinguish between a propyl and an isopropyl. What would an isopropyl look like? Yeah, it would attach like this. Be a propyl group, but this would be a methyl isopropyl amine. Methanamine or methylamine. Dimethylamine. 1-aminopropane. Or just propylamine. Propylamine would be the simple. And then this one up here, we've got diethylmethylamine. Diethylmethylamine. By doing that, we don't need to use a bunch of N's in the name. If we went into an IUPAC name, would it be N-methyl, N-ethyl, ethanamine, something like that.
What's the first one?
This one is the top one, way up there. Okay, let's just do one more here. Along this line here, I want you to grasp why we would have to do this. Let's say we had a molecule like this. 1, 2, 3, 4, 5, 6, 7. I just made the molecule a little bit bigger, and now I got a methyl group on the nitrogen, I got a methyl group on the chain, so now name that molecule. Can everybody see it? So the longest chain is 7 carbons. So it could be, we can just call it heptane. The amino group is on carbon 2. It's 2. Oh, wait a minute. wait a minute. It's going to be 2-aminoheptane or 2-heptanamine. And then here's how we would handle this thing. This is carbon number 1. This is 2, 3, 4, 5, 6, and 7. So this methyl group is on number 5. We're going to have an N, 5 dimethyl.
Professor, but you need the N is not at number 2?
Yeah, the amino group is on number 2. On that amino group is a methyl group on that nitrogen.
Well, where you put the number 5 then?
So,
There's also a methyl group on number 5.
Oh, so you're saying that one methyl is in the N.
And one methyl is on the carbon number 5.
I thought you were saying that the N was in the number 5, but it's not.
No. These two things here, they're on both numbers, there's an N and a 5, are telling you where these two things are. One's on the nitrogen, one's on the carbon number 5. Carbon 5 is a position, nitrogen is a position.
so we could not have put 2, 2, 5 dimethyl, 2 amino. That would be wrong.
Yeah, it could be, this could be out here, 2 amino and 5 dimethyl heptane.
Or could it be 2 heptamine?
Yeah, it could be 2 heptamine. So N5 dimethyl 2 heptanamine. Did we say heptanamine? All right, N5 dimethyl 2 heptanamine. And what is this 2 referring to? It's referring to the position of that amine. It's on carbon number 2. Okay.
So either way is correct.
Yeah. So it almost seems like there's no bad way, there's no incorrect way of naming it. There is an incorrect way of naming amines. There are 3 or 4 correct ways of naming them. So I don't know if that's encouraging or discouraging. I think, man, I'm going to take a stab at this. There's 4 accurate names. Okay, here's aniline. We already introduced aniline. I'd like to introduce aniline to get into the N's, because then you can see the N-methyl. So here's N-methyl aniline. Here's 2-ethyl N-methyl aniline. Here's N-ethyl N-methyl aniline. So each one of these substituents has a designation to show where it is. Whether it's on a carbon on the benzene ring or whether it's on the nitrogen. All right, so these slides are there to go back and say, okay, let me look at these again. And what are they talking about? So N is a position on an amine molecule. If there happens to be something on there. Okay, before we go on, let's classify these. Is this a primary, secondary, or tertiary? Primary. Primary. That nitrogen has only 1 carbon attached to it. 1 carbon. It's got 2 hydrogens. This is primary. Secondary. This nitrogen is attached to that carbon, and this methyl is attached to that carbon. Yeah, it's not, this carbon is not attached to that hydrogen. It has to be attached to the nitrogen. Why is that not ambiguous? Because you will never see carbon between two atoms. You never see that. Hydrogen can only form one bond with something else. So when we write NH methyl, we really mean this. That's what that means. And then if you got this attached to the six-membered ring, you've got a carbon here, and you got a carbon here. So this is a secondary amine. This is a secondary amine. You still got one hydrogen. This is a tertiary. Just keep saying tertiary. You'll be right one of these times. All right? And you were. I won't have you memorize. Toluidine is an amine and a methyl on it. Toluidine, it's just a common name. But don't worry about that one. This is the one you need the 3x5 card of. Know what aniline is. Okay, properties. Let's take a little break. We'll talk about properties of amines. Let's take a break for about 6 minutes.
I know, I didn't spell it.
This one?
But I know how to spell it. So you were trying to there you go.
Well, but go with aniline. Don't.
That's what I was saying, aniline. She goes, no, it's a benzoaniline. I said, no, it's aniline.
Yeah, go with aniline. All right.
Or the benza.
You like that name? I think if you went on the internet, it would have both of those names, but chemists very rarely would call that benzamine, called aniline. 95% of the time, we're going to refer to that as aniline.